Can you hear me?
Yeah, I can hear you. How's it going?
Yeah, it's good.
Good. You in the new place today or same place?
No room.
Cool. Nice. Cool. Great. Well, I'm actually excited for today. It's gonna be a fun thing we're building.
Yeah, I I think it's been a week. Right?
Yeah, I can't remember, but there's been so I've been coding so much, but yeah, we we get some. I think last time you had like a small bug in the WebSockets code or something like that we fixed, right?
Yes, yes.
There was a small bug with like the multiplayer mode, right?
Um, yes, I think we had to start the AI development and then we were short on time, so we stopped.
Yeah. Cool. Um, you can hear me okay, right?
Yes, exactly.
Good. Let's for today. I want to make the AI that's going to control the tic tac toe. Yeah, the tic tac toe game. And I think we should do this in. Oh wait, are you you're using TypeScript?
No, this Python.
Python. Oh, perfect. Good, because I wanted to use Python actually. So my thought is that actually I can create a one sec. I can create a collab notebook, and then we can kind of work together there. And
Okay,
yeah,
so like Google Colab, I think I heard of it.
yeah. I'll just make it. I'll just make one right now, and I could add you to it. But actually, we could probably just share a screen because it's more of a problem solving than a coding. What we're gonna do. So let me
Yeah.
share.
Let me just turn on the light. It's a little bit dark.
Sure.
Okay. Now it's a little better.
Cool. Yeah. Let me share my screen here. There we go.
I thought that it was going to start at 10:30, but the notification came at like 9:50. I was like, "Eh, it's starting right now."
Yeah. I just get the calendar. I just get them inserted into my calendar, so I don't do any of the time zone checking
Oh,
or
so it's all automated.
whatever you chose. Um. So yeah. Just cool. Yeah. So here it is. And I was thinking we could just kind of work through this problem together. For how we're gonna make a tic tac toe playing agent, and yeah, um, it should be fun. So I can sort of walk you through a little bit the way I would think about it myself, um, if that makes sense.
Okay.
So basically, we're trying to create a function, right? And the function should give you like the best move, and that should be for a given board. So like the current piece positions, and for which player, of course. Like you have to know whose turn it is now. And then the other thing, so yeah, so that should give you the best move, and we have to figure out a way to define this function, right? We have to fill in this function, and when this function is working, then actually we could write some tests, right, to start. You know what I mean? So
Let's see. Yes, yes.
so let's say for the tests, maybe we have like best move and Do you have a particular format that you like to use to define the pieces on the board? Like, do you use an array, like a list of lists or a string? How do you
Uh,
normally?
like the remaining moves and the doubles moves as well.
What did you say?
Like you mean the moves that are remaining or the total moves? Yeah, those things.
Yeah, the audio is kind of dirty sounding, but um,
No, not
that's
really.
okay. I can hear
Don't
you.
think.
I can hear most of what you're saying. So yeah, the question is like the board is like, for example, would you do um, something like this, to uh, define the player pieces? How would you do that? How are
No,
you?
no, no.
How are you doing? Are you doing it?
Let me show it. Let me show it. I get it. I get it. Let
Yeah,
me do this. Can I share the screen?
sure.
Please,
But it doesn't. But
screen.
for this case, this is really just a convention here. So you can tell me however you want me to do it. Just so
Okay, so I'm using an array for that. Let me just show it to you.
so a list of 9. Is that it?
Let me post it in the chat.
Okay.
So we can say,
Cool. So
so here I have defined all the winning moves in which is particular person can win. Like if all the upper boxes are filled with X or O, then that one wins.
sure. Oh, okay. So the way that you are, um, okay. So you have upper left, upper middle, middle middle, bottom middle, and so the way that you're actually defining the board positions now is something like you'll just have like X's, and then you'll have upper middle, something like this,
Yes.
upper middle, and then like middle middle.
Like it starts from upper left and it goes to upper middle, upper right, then middle left, middle right, bottom left, bottom middle, middle right. And that's how I cover all the indexes.
Yeah. Okay. Cool. Yeah, we can do it that way. I don't see why not. Do you want to we can use this. So we can use this function. We can define this function here. We might as well define it exactly the same. So um, so I would do something like this. We can define a function called isWinner, and we can say like board player, and we need this. Yeah, the rest of you can maybe actually I have access to the Git repo, so I can copy this as well. But let me just, because I didn't get the full list from the chat. But so you have something like this, right? And then we just want to see, and then we'll just have like, okay, so these have to be always in the right order. Is that right? In the same order.
Yeah. No, I think there's a better approach. Like we can just define a variable that will store all the moves that are available currently. Like if player chooses upper left, then we will remove that position from the total moves left.
Got it.
So yeah, so the function will check what are the remaining moves,
Yeah.
and it will go next.
Okay, cool. Yeah. Yeah, that works too. We can make a function that just like complete this function to see F the
Let me
move.
just turn off the fan. I think that's the reason my voice is not good.
Yeah, that's good. I can't exactly tell what you said. Complete this function. See if the moves given are, are winning moves for a Tic Tac Toe. So this will be faster than me even coding this out. But so, for example, if you have something like this, where you have all the possible winning moves, right? And then we put in the player moves into the function. And here, oh, this is great Python here. So this is checking if, this is checking if the player moves are equivalent to here, or rather, if they intersect, if this completely fits in the player moves. So it's doing it as sort of a set comparison. That's really nice. Really nice way of doing it. Does that make sense?
I think yes.
Yeah. It's just checking if all of these are in the player moves. That's a great way of doing it. I would not have thought of. So then I'll just define a test case. Okay. And why is it defining the board? Oh, because we don't actually, the board is not necessary anymore, because that's what the player. I was thinking of it that you would have like X's and O's, which would be a different way to define it, but we can just do like exactly like this, and then define a test case. And these would be some some nice test cases that we have to show that this function is working. And actually, I want to say, like, for each test case, also print the board. That would be really cool. So that we can just visually check it. And, well, good enough. Let's define this. So yeah, I would have hoped that it would print it a little nicer, but that's fine. And then here it's given two very easy solutions. The first one's passed. The last one failed because it actually, the test that it created did not pass. So interesting. So it thinks, so this one failed because is winner should be false, right? And then here, upper left button, middle left button, bottom left. Okay, yeah, so the tests it created were wrong, actually. Do you see that?
Okay. Yes.
Do you see? So
Mr.
the function is actually correct. This one, as far as I can tell. But we have that there twice. But the test it created is actually wrong, because it drew this board, but actually the board is, the player has more moves than that.
Upper left, middle left, and it forgot the bottom left. Okay,
Yeah.
and it then added the last two. I don't know why.
So that's pretty interesting. Oh, we had a couple people join in while we were playing around with that. We had Ahmet and Moise joining in. So hey everyone. And yeah, so these tests created by GPT were complete crap. Maybe if I did that, again with actually, I want to try it again with GPT-4, because GPT-4 should not get that wrong. Create 3 test cases which both print the board and show if the player is winner. I think we're gonna finish this today. Actually, I mean just this algorithm. So yeah, this is what I would do: is I would define like a print board function, and then I would print for each test case, and the only thing like a little bit complicated about doing it this way is that we have to be careful that we don't end up with any players that have pieces on the same square. So we'll have to always check that. So GPT-4 is a little slower.
But it's thinking correctly, I think.
Hopefully a little smarter. So we have is winner here. Okay. Oh, this is nice. It also printed to the board nice. Winner, winner, no winner. Okay. So we know that this function works. I believe it works. It's got all the different conditions. So I think this is a nice way to do it. And now we have to get back to our original problem, which is how are we going to decide what's the best move? And so given this, we should get out something like one of these moves. And we'll also, I guess, rather than board and player, I had been thinking of it a little differently, but I guess we would do something like, so we could do
I
something
think
yeah.
we can do like we can loop this function so it gets every move. We can give it a single move, like if we give it upper left move, then it will return. What is the possibility of winning with that move, and what are the possibilities of losing with that move?
Okay.
So
Yeah. That's definitely one of the hey AI stories. We're making an AI today to play Tic Tac Toe. That's
greetings.
definitely going to be sort of like a sub step of this. So if we want to get the best move, we can have like move success, checking for one move. So like for example, if we'd have here my moves and or maybe like my pieces or my moves. Like I wanted to show these are the pieces on the current board, and then opponent pieces. Given that, I should get move success, and then by having like this, well, given that I should get one move, and then here, if you want to know the success of one move, we would need to know what are all my pieces, what are the opponent's pieces, and then what move do you want to check? Does that make sense?
I think yes. AI Stories said awesome project.
Yeah, this is an awesome project. So basically, the way I'm thinking of kind of combining the best move and the move success function, which basically
Wait, it's getting a little over my head. Let me just let's just rethink everything. So,
sure.
firstly, like firstly, the AI will be playing against a human opponent. Like James is playing against the AI. So, like James makes a move at the upper left and the middle left. So you only need one more move to win, and the AI needs to determine where it should place its move. So it will, I think, in the best move, it should get available moves and the opponent's used moves. Like what moves has the opponent already played, and then it will check every possible outcome, like which will be the best to play the next move. Like it's a little bit confusing.
Yes.
Overlapping things.
So let's start by I'll change my language to match the language that you're using. So rather than my pieces and opponent pieces, I'll say AI pieces and human pieces. I'll change
Yeah,
it to this.
I think that.
And the way I'm thinking of that here is AI pieces and human pieces are lists of position, like that. If that makes sense.
Yes.
Does that make sense?
Yes.
And then here, this move here. This I could also call this position. And what I was thinking, because we need a function to tell us what the best move is. So, check each move and give the move with the now. So this is the way you're thinking of it, of the highest likelihood of success, right?
Yes.
And so that this kind of, I didn't spell that right. This kind of makes sense for like a chess type thing, because everything in chess is all going to be you cannot have like the complete solution in chess, right? But in a tic-tac-toe game, actually, if both people are playing correctly, each move is either like a good move or a bad move. You know what I mean? We can calculate the whole thing, right? So rather than like a likelihood, wouldn't you rather have like a 1 or a 0? You know what I mean?
I think yes.
Because imagine we're playing tic-tac-toe. If I do, and I look at all the possible moves that I have, every move is clearly a good move or a bad move. There are no 50-50 okay moves in tic-tac-toe, right? There's not like one move where it's like, if I play this, oh, it's 50%, like 50% sure I'll win. It's like going to be a bad move or a good move. You know what I mean?
Yeah, it's like either win or lose or a tie.
Yeah, as long as the opponent is good, as long as your opponent is good, then every move is good or bad. You know what I mean? So what I'm suggesting is that we would actually call this function here, like is good move. And this will actually make it easier for us, because, well, let's open a tic-tac-toe board. Oh, perfect. So,
Wow.
so here, imagine imagine this is the game board right now, right? So we have two kind of arrays here. And each array has just one piece in it. Is this one a good move? Here?
Currently, yes. Every blank box is a good move.
Yes. This one is good. This one. This one is good. This one is good. This one. This one is not.
Not good. This one is, yeah.
Yeah. This one is good. This one is good. This one is good. So I'm thinking, and it doesn't really matter which one we choose, right? Does that make sense?
Yes, I think If every player has making one move, then I don't think there's any point to uh, choose a specific box because everything is just fine.
So sure. I mean, so then you would just choose one randomly? Your AI would choose one randomly?
Yeah.
Well, let's say we choose this one randomly here. Right. So if I'm going second, my goal is to get a draw.
Yeah,
No.
we'll always make the AI go second. That's the main goal.
So the goal of the AI would always be to get a draw, not to win.
Yeah, either to make the opponent lose or either
Got
to
it.
make it a tie.
Okay, yeah, or to yeah, if you can make the opponent lose. Right. That makes sense. So in that case, yeah, in that case, maybe this would actually be do you think this is still a good way to define the function, if it's a good move or not?
Um, uh, I think I have an idea.
Sure.
How about we copy the AI pieces variable into another variable and we loop through. Uh, Let me just ask this. What does the variable AI pieces contain?
It contains a list of these. It's just like this.
How about scroll a bit, scroll down a bit. Okay. And okay, so how about we replace that with the remaining moves, like the moves that are currently available to play, and then we will loop through those remaining moves, and for each move we will call the isGoodMove function, and we'll give it that move as a input.
Mm-hmm. Yeah, let's do that.
And
Yeah, let's do that. So I would say I would even say this. Um, give me a function that given a list of moves returns all the other moves that aren't in that list. We could have like an inverse function that might be useful to have to do this. GPT-4 is cranking on. But so my thought is that we could do exactly what you said. So we could say, for move in like inverse of AI pieces. Does that make sense?
I don't know what inverse means. What does that do?
So you had just said like instead of taking all of the pieces, we need to take all of the moves that haven't been played, right?
Yeah, the remaining ones.
Right. So actually, we would want to be able to take, to be able to find all of the empty spaces on the board, right?
Yes, then we'll just select each one of the empty spaces one by one, and then we'll check that if we select this one, what will be the next move that the human can make,
Yeah.
and how does that affect us?
Yeah. So we'll have to first figure out what are all the empty spaces, right? And
Yeah,
so basically, that would be something like this. And Yes. So we could have a function that basically, yeah. Let's have a look at this function here that GPT just came up with. So what this function does here is let's just give it player moves and AI moves. And what it's going to do is it's going to, it's going to given all of the places where the player and the AI have pieces, it's going to give all of the empty spaces. Does that make sense? Yeah.
Yes.
So basically, let me use the same notation for both, like that, and AI pieces, human pieces. So exactly. And then you want to know, like, if is good move. Move,
Yeah, exactly. Yes.
then maybe this is might not be the best way to do it, but this is basically how we're thinking through it, is to return that. Now, then the question becomes, how do we know if something is a good move? Well, originally I was thinking of this from the first player's perspective, where we're trying to win. But here there's three scenarios. There's win, lose, and draw. So I actually hadn't thought that out the first time I thought this through in my head. And maybe, just a thought, maybe it might be better to do sort of like you were originally saying, where we give it a score.
Yes, that's how the min-max algorithm works. So if it's like, if we won, then it will return plus 10, like 10 scores. And if it's a tie, it will return 0, because a tie is a tie. And if we lose, then it will return negative 10. So the computer will just check which one's greater. So that will be
Cool. Yeah. So in that case, I would just rewrite this bit to return the move with the highest score. And then it's just going to use move score gives the score. Find the max score of all moves and return that move. This is like a pretty elementary. Let's see if this is. Sure. So for each one, it's just checking the score, and then if the score is better, it's saving that one, and then finally returning the highest score. So that's a sort of just a way to check and find the maximum. And now we have to do the fun part, which is to come up with a way to score. We can come up with the scoring function.
Can we both work on the same Google Colab?
Yeah, do you want to type on here?
Yeah, sure.
Because I feel like you could actually just sort of describe how I can solve it, right?
Yeah, we can just both display our cursors.
If you want. Is there something that is hard to describe that you want to type out?
No, no,
Okay.
no, no, no.
Oh,
It's just that I
you
want to see the code in person.
oh, it might be easier for you. Yeah, sure. Let me do that real quick. Okay. You should be in here.
Did you share it?
Yeah, I did.
Where?
Gmail.
Okay, let me just check it. Oh, okay. The auto refreshes.
Yeah.
Okay, I can see it. Okay, so my cursor is being displayed now.
Mm, no.
Oh, not the cursor. I meant the keyboard, that blinking dot. I don't know what uh, its name is.
Where is it? Yeah, where is it? You can see my
Let's
screen.
just let me just try typing something. Can you see it?
Um, no, I'm not sure that collab works that way.
Okay, so it doesn't work that way.
Yeah.
Uh, Wait, do I need to connect?
Yeah, I'm not sure that collab works that way.
Okay. I think I have a bit of history with
Problem.
Google Colab. It
This
has banned me from running any cheap RAM and resources. So
it shouldn't be a problem. I've never had a project where I need to have two cursors in order to solve a problem. Like,
okay, let me just see it like this only. So we have a remaining moves function and best move. Okay, so I think I have an idea. We'll write it in the VS Code and I'll just share my screen. Hmm, create a new file. Let me just share my screen right now.
mhm.
Let me just share my screen. Okay. Hello, can you hear me?
Mhm.
So we have this. Okay. So how about um, and also like uh, what are all the moves that are possible? Upper left, middle, upper left. My typing is really bad right now. So I'm currently defining all the possible moves. Like, wait, why am I writing button? So how about we do it like this? Can you see my screen?
Mm-hmm.
Um, Let me just comment this right now. Uh, so we will also get the remaining moves. Where's that function? Remaining moves. Wait, what's this? Okay, I have a better idea for that. Let's just say remaining dash move equal total moves, because at the starting we have all the moves as remaining moves, and as the player starts making some moves, we'll just remove that specific move from remaining move. Like if the player chooses this upper left move, and we will just remove it from this array. So the remaining moves will be these after that. Mm, then what do I need to give the best moves? We need to, let me just create another variable for this. Let's just, mm, okay, so now we need to randomly select a specific move, like, let's say this one's occupied and we select this one, then um, it selects this one currently. So we need to also have an array for opponent moves that will have all the moves taken by the opponent. And for um, wait, let me just pause this screen sharing for a second. Mm,
So I see
okay, so
what you're doing
okay,
there.
go on,
I see what you're
go
doing.
on.
Um, but I don't think we've gotten closer to solving the problem by doing it that way. I think it's another way, just another way of writing the same code, right?
Let me just, I have implemented it a little right now, so let me just show it to you. Just wait a sec. Okay, so I'm gonna share it right now.
Mm-hmm.
Is it being shared? Hello?
Yeah.
Okay, I think the internet is a little slow. So I have implemented this right now. So it will calculate the computer move. Like the score is zero. That one we talked about, like, the score one. And this checks if the index is one. So that index means the total moves that have been used. Just forget this one. And else it copies the used moves, like it also calculates the used moves. That means we can also call it opponent moves. And okay, I'm doing that here. And then it just copies total moves. And here is the main code. So for move and dummy moves, like it gets every move from the total move and it appends my move. That is the used moves. I know I'm not good at naming things.
Mm-hmm.
Let me just make the comments a little more defining. Um, which is selected.
So does this code work? And if not, what's missing from it?
Let me just show you this one. So I had implemented this like yesterday, but
Mm-hmm.
the main problem is like, let me just copy this because it's in another folder, so I won't be able to run it directly. Implementation. Okay, so now we need to give our name. Let's choose upper left. I forgot. Do I need to choose button? So in the first move, like I said, it doesn't matter which one we choose. So it can be like random, because it doesn't make any difference wherever you play. So the main role is of the second move. So if I choose upper, sorry, not upper one, let's just say middle left button. So I'm trying to cover all the left blocks. And after this, it messes up a little bit because um, it then checks every possible outcome. Like it checks what happens if it plays upper right at the upper right corner, and then it checks what happens if it plays at the bottom left, and then it checks. I mean, it's a little bit confusing, but I need to edit it a little bit to make it run. I get a feeling that it will work if we make some changes to it.
Well, what do you think has to be changed?
Um, okay, let's just try to understand the whole code. Here we have all the winning moves. Here we have the total moves that are possible. Here we have opponent won, that is false. I won, that is also false. We have used moves of opponent, that is also a list, and our used moves, that is also a list. And we have a function to remove a move from used move. And okay, so it's a little bit confusing.
I think you have, to be honest, I think this code is a bit confusing, mainly because a lot of this code has to do with managing the state. But the only thing that matters, the only thing that the important part is the scoring function, right?
Yes.
Right. That's really the only challenge here is how do we come up with the scoring function that tells you whether
Yeah.
one move is better than another.
Yeah. That's where it's messing up a little. So let's just see. Upper, where was I? Bottom left. Okay, so it's creates an exception.
So can I just suggest maybe a slightly different way of thinking about this?
Yeah, sure. Why not?
All right, here. So let's have a look at my screen here, and we have a tic tac toe game, right? And let's just walk through it. So the first move is the human, right?
Yes.
Always, and then it doesn't matter which move the AI takes, right? That's what you're telling me, right? So if the human goes
Yeah,
here,
yeah. So yes.
if the human goes here, um, the AI can
It's
go
random. It's not decided. It's random. It's just random. It's not like a specific point.
right. But I'm actually curious. So if the human has gone here, would it ever make sense for the AI to go here? Is it the
I
same?
mean, why?
Is it
Why not?
is it equally good?
Because yes, because it can just go like the AI is currently playing in the upper right corner. You
Hmm.
mean if it plays at the bottom right,
Is that
that's not.
is that an equally good move as well?
Yes, it's equally good move because the whole upper line is empty for it to score a win.
Yeah, I guess the way I was thinking about it though is that if the human goes here and then the AI goes here, and then the human goes here, well, neither of them have progressed very much, but it feels to me like the human is ahead then. But maybe that's just maybe you're right. Maybe there is no maybe the first move is not it doesn't matter. But let's say we have these. Let's say we're here now and we have two moves, right? And then let's say the human will obviously go here, right? Now, how would we calculate? Ignore that the AI just did this. How would we calculate? I think this is really the question that we're trying to get to. How do we calculate that this is the best move, right?
Yeah, so that's why I was using these arrays. Like there's one array for used move, there's one for remaining move, there's one for used move by the AI, and there's one for used move by the opponent.
Sure.
What we need to do is we need to check every remaining move after the human makes a move.
Mm-hmm.
And then we need to check if that move results in a win
Mm-hmm.
for a human. Like if the AI, let's just forget that AI has played in the upper middle corner. Let's just forget that one, that round
Yes.
for now.
Yes. Exactly.
And so the AI currently has only played in the upper left corner, and it will then go from upper middle, upper right, and then like every block, then it will check like it has selected upper middle block, right?
Yeah.
Let's just pretend it has selected upper middle block in the for loop, and then it will check if I play this block, does the human win? Like it will have another for loop that will have all the remaining moves. So if the AI has played in the upper middle, the remaining moves are upper right, middle left, middle right, bottom right.
Right.
So it knows that the human can't win. It will just compare it with the is winner function, and it will check that no, the human will not win in this case. So I guess this is the best move.
Right. Okay. So I think the way I'm understanding you're putting it is that like if I'm the AI, the first thing I want to do is win. If I can't with my next move, if I can't win with my next move, the next thing I want to do is block any winning moves for the human, right?
Yeah, yeah, exactly. Yes, yes.
Priority one is to win. Priority two is to block any potential moves where the human could win. And so that's our strategy so far. And then if there's no winning and no blocking moves, then can I just randomly put a piece on? Is that all?
No, there will always be a blocking move, I think, unless the human is like stupid.
Yes. Yeah. But so that's my question. Like, um, I mean, so can we sort of simulate? How would we simulate that here? So like, actually, here can I do this as Is it possible that I can do this as without an AI?
Why don't you use that one, mine one?
Is it online?
Oh no, it's not
Okay.
online, but
Let's, here I'll just
okay, yeah, yeah, yeah. Go to that website and just select 2%. Yes.
okay, cool. So we want to see if this strategy will always work. So first try and win, second try and block, right? So let's say I'm the human and I go um and then well actually that's too easy. This is let's go to let's say the human goes nah two players. Let's say the human goes here. The computer will choose something randomly. So let's say here. And now let's say the human. So here, these are all good moves. This is a good move. This is like a bad move for the human, right? Here.
Yeah.
So let's say the human goes here. Now, the first thing the AI tries to do is win. It can't win. Then it tries to block. It can't block. So now, how do we calculate what's the best move for the AI?
So in that case, I think we can just try to make our way to win. I think we can just mark the middle right one.
Mm-hmm. Well, it seems these two
So
are.
that will,
It seems these two are both pretty good, right?
yes, because that will make the AI a step ahead of the human.
Right. So,
But that I don't think that's ever gonna happen because everyone knows how to play tic-tac-toe. So, but
but then,
we do need to think of every possible case scenario. Yes, that's
yeah,
also.
yeah, we have to, right? Otherwise, why do we even program it to try to win?
Yeah.
Because there's no, um, yeah. So, yeah. So we'd have to consider this case as well, and so you could put. So how would we code that in? I guess is really the question. How would we score? We have 1, 2, 3, 4, 5, 6 possible moves. How do we score these? How do we come up with an algorithm to score these?
I think for now we can just
You want
say like
to add that in later.
play. Yeah, yeah, yeah. Leave it for later. We can just print you are not worthy opponent.
Okay. Yeah, so my idea was to try and come up with something that would solve that. I honestly think that's the whole fun part of this challenge. But if you want to, just for today, since we don't have too much time, to just do just those cases, that's also fine. Yeah. We can do that way.
Let's just focus on the cases in which the human is a little smarter.
Sure. Well, in that case, we only need to block.
Yeah, yes.
Okay. Yeah. And then there's only blocking. Okay. Yeah.
So firstly, it will check if it's if the move is the third one, because if it's the second move, the first move will be of the human, and the second move will be of the AI. The second move will be random. We can use just the random library, and we can just select any random place. And the main part starts at the fourth move, because at the third move the human will like try to make its winning, and at the fourth move we will try to block it.
Mm,
So we need to start the algorithm at the fourth move.
okay. Okay. Go. Human, computer, human, computer. Cool. And at that point, we're trying to block. Um, and if there's nothing to block, okay. And so then once we block, then we're expecting to block again after that, right? Until we
Yeah,
until,
yes,
until we reach a draw.
yeah.
Okay, that should be doable. We can do that. Cool. Do you want to show your code?
Okay, let me just. I wrote this code like I don't remember how this code worked.
Um,
Sometimes you forgot how your own code works.
yeah, for sure. I think we don't have to use this code. I guess I think, um, but it's probably very close to correct, right?
Wait,
Because
let me just check. Okay.
yeah.
Okay, so the first bug is that your choose move. Wait, what does your choose move does? Okay, so if it selects the upper right, okay, I get it. So we have selected upper left and middle left. Then it starts looping through each remaining move. So it selects upper right button. Yeah, I remember. It selects upper right button as its move, so it checks every possible outcome that the opponent can make if it selects upper right button. And then it sees that there's a winning case in this one for the opponent, so it goes through the next one. But
Yeah.
I was confused that why does it select bottom left instead of like uh, uh, bottom middle or bottom right? I was confused at that because, let me just open the Tic Tac Toe website that you were using.
Mm-hmm.
Uh, oh, no, it wasn't this one, it was this one. So, like, the next one will be random. Like, let's say we played here,
Mm-hmm.
and I have defined it in here that if the human plays the first move anywhere in the possible moves, the second move of the AI should be here, every time here. If the humans chooses this one as the first move, it displays an exception because I've just not coded it yet.
Okay.
So the problem is that the human has selected all these moves. Like this is the case. This is the case. So it should start from here, upper right. It checks that, yes, upper right has been checked, and it checks that there's a winning case in this one for the opponent. So it will move to the next one. And I don't know why the next one is bottom left. It skips some of them. Like the next one should be this, right? Bottom middle. But it just, oh, sorry, middle middle. It just goes to the bottom left. It skips these two.
So um the AI here is the O, right?
Yes, yes.
And we want it to go in the bottom left, right? Um
Yeah, we wanted to go here.
so is it choosing the right move, but it's not checking all of the moves that you want it to check? Is that what you're saying?
It's like both of the things. It's not choosing the right move, and it's also not checking all of the moves. Like it checked the bottom right button. Bottom right is this one.
Yeah.
It's checked the bottom left. We needed to check the bottom left. Yes, it checked the correct one, but it didn't stop there. We needed to stop if there's a, um, your opponent won. What does that mean? Wait a sec. Okay, so if in any case the opponent wins, it prints your opponent won, but it didn't print in these. Yeah, so as you can see, there are a lot of bugs in this code, but it is kind of the main blueprint of
Uh-huh.
how the algorithm should work.
Uh-huh. Cool. Um cool. Yeah. I guess it's really hard to see what it's doing without putting in a lot of print, without just putting in some print statements. And then
Yeah, so when it chooses this one, bottom left, as you can see, it chooses it here. Your choose move, bottom left button. Your choose move means the computer's choose move,
yes.
bottom left. I was expecting it to trigger this if statement and quit the program and print move on, but it's not doing that. Else it's doing this. Move on equal no one, and then it just goes
Hmm.
to the next possible.
Well, I guess you're probably gonna have to break it down into more pieces and just add some more print statements because it seems like you know exactly what you want it to be doing.
Yeah, firstly, we need to figure out why the hell is it skipping some of the statements. Like, yeah, these are not those. But yeah, this one's correct. But how did it get here? Why it skipped two moves? Like, where did these two go?
Yeah, there's definitely a bug there. Well, would you like to? I mean, we're kind of running short on time now. Would you like to maybe do a bit of debugging and then show me when you've gotten out some of those bugs? Because I think if we look for that bug, if we just are digging in there, we'll probably be here for another hour or maybe at least half an hour, right? How does that sound?
Yeah, sure, why not?
Cool. Yeah, I mean, I look forward to seeing it when you get that small bug out. That would be that would be cool.
Yeah, I will try it. We have ChatGPT as an ally.
Yeah, and I think like just an idea, like maybe you could just like come up with a good way to print the status, like some maybe kind of like use the visual way to print as well, so you can kind of get your mind around what it's doing. I guess just a lot of print
Yeah,
statements, right? Just a lot of print
yeah,
statements.
yeah. It's a little bit confusing. Yeah,
It's
it's
like
like a log output.
yeah, exactly. So a lot of print statements and then print statements that you can understand as well. Like you'll figure it out.
And
Way.
Yeah, the code that you generated using ChatGPT, I think I have gotten an idea with that. It's not that easy to explain, but I think I
Yeah,
will use it
this is pretty
because
nice, right?
yeah, I have a little uh, way to solve this bug, and I will be using the function that you created. Where did it go?
You don't have a Copilot, do you? You don't have GitHub Copilot, do you?
No, 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 I don't use that.
Okay, but ChatGPT will be just as good.
Yeah, that's gets the job done.
Yeah, cool, nice. Well, nice work. It seems it's close. Great. Are you working on any other interesting projects recently, or learning anything else?
Um, I was talk about learning something new. I went to college today, and my senior asked me to help him to create a Java project.
Mm-hmm. Cool.
Uh, I mean, I know a little bit of Java, I know the basics, but I have never created like something useful, like a weather app or something like that.
In Java, yeah.
Yes. Have you used Java?
So recently, I guess a couple of days ago, I got a request from someone that wanted to make a game, and actually, yeah. Let me show you all of the. Actually, yeah. So someone basically wanted to make a game, and let me see if I can open it up. They had asked, um, and I said, so what programming language are you using? And they said Java, and I said, it wouldn't be my first language I choose to make a game. But actually, right now, it's not even working. Well, I had basically, so what I had done was I had went to Replit and gone to Replit, and then I created a new Replit, and I went to Java, and then Swing. So like Swing is a graphical user interface, a toolkit for creating stuff with Java, because like Java doesn't really natively support user interfaces. So this is a Java program with Swing. And I was, because they had asked me, can we make a game? And they use Java. So I was trying to think like, oh, would that be even fun? And so I generated like a little bit of code. Yeah, here. To make a game with Java. And so this is the default Replit template. And so it's 28 lines of code, and this is what you get. Well, this hello world,
Okay.
and beautiful. And this is the kind of interface you can make. And then so I was like, okay, that's cool. What can I do? What more can I do? So I created this simple project. Um, I mean, it's a bit more complex, but basically this is a simple Java game, and like you can see with Swing, it's still sort of compiling, and basically it uses this stuff like add key listener, set painting rects, painting rectangles, and that's sort of what Swing allows you to do. And if this is working, yeah, okay, I have this this little Mario. Okay, so here I need to drag this down a little bit, maybe. Okay. Oh, okay, perfect. So now I've created um, feature complete version of Mario here in Java.
Nice.
So yeah, I
That's
mean,
amazing.
can I didn't write most of this code, but um, you can do stuff like this in Java. I think I would prefer any day to use JavaScript. So it depends what you want to do. Yeah.
Yeah. like they asked me to build something useful and help them in that, uh, like a weather app or a simple calculator. But this is advanced stuff. Like it's getting all the keystrokes.
Yeah, I think my main takeaway from this is that like Java itself is not very difficult as a programming language, but I don't think I could make a good UI using Java. Like, I just don't know what
Yeah,
like, yeah.
we are a little used to like JavaScript and CSS. So
So I like here on Stack Overflow, um, looks like this got shut down probably because of flame wars or something like that. Um, People are asking, what's a good framework, and then there's all of these options. So I've never heard of any of these actually. So I think probably there's just not any great options for making UIs. So he says like this is pretty low
um,
level. Maybe Apache Pivot, demos of what you can
okay,
do.
so these are like Java libraries for creating GUI, like
Yeah,
tkinter and Python.
exactly. So like that's the difficult. Yeah, exactly. So Python has some similar stuff, and like Python, like it's gonna work, but it's not gonna be like the most beautiful UI you've ever seen, right? um, you used to be able to make Mac OS apps with Java. I'm not sure you still can, probably, but I don't know about making something beautiful. I haven't seen much. You'll be able to make something like this. You can make calculator, you can put buttons, but yeah, JavaScript is going to
Yeah,
be
I've tried to make little things like if like I have a button, anyone clicks that button, it says hello and something like that, but not the fancy stuff.
yeah. um, I
And
also
I also
noticed
have okay, go on.
no, nothing.
I also have one more project in mind, but that's related to Python and JavaScript. Like we can, have you ever heard of a website called Pairdrop?
Pair drop?
Yes.
No, what's that?
Mm, wait, there are many implementations of it. I don't know if,
Okay.
yeah, yeah, Pairdrop. Like it's a website for file sharing. So if you
Huh?
want to share files between two devices, like your computer and your mobile, so you can just open that website on both of them if you're connected on the same Wi-Fi network, and you can just share files using your Wi-Fi network on a website without installing any software.
Does that also use WebSockets?
Yeah, 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 exactly. It uses WebSockets. So I think I'm not sure, but I think the server checks both of the IP address and then tells them that, hey, you are both on the same Wi-Fi. So I guess you both can share files.
Cool. Oh, that's pretty cool
Yeah,
idea. Based off IP address.
yeah, yeah. I think we can also implement that because I think that's not gonna be this hard. Like them making the AI for Tic Tac Toe, that's gonna be a little bit easier than this,
Oh,
but
really?
it's gonna be interesting.
I think it's harder.
No, no, no. This one's harder. This one's harder.
We can do this. We'll get it. We'll get it. Just try and do a bit of debugging, and
Yeah,
next we'll finish it. All right.
yeah. And another one I thought of like that was using the WebSockets again, sockets or WebSockets,
Mm-hmm.
and we can create and like we can run a Python script on your laptop or computer that will host a Flask server on your local host network and that you can access on your mobile.
Mm-hmm.
that will have like buttons and things like that, stuff like that. And those buttons can be used to shut down your PC, open a specific website, or I mean, close a specific task or things like that.
Yeah. Oh, that's a cool idea.
Yeah, so we can just like use libraries like, have you heard of PyAutoGUI?
Heard of that. Yeah. Okay, that
Yeah,
makes sense. And that would have like a server, and you could connect sort of like a smart home, you know?
yeah. So like you can just you can also implement the login or I mean the password things, so no one else can get into it. But the main idea is controlling your PC from your mobile. So like shutting it down, restarting it, accessing the terminal, downloading files. We can also implement downloading files.
Yeah. Cool. Yeah, I even found this repository. Maybe there's more. I even found this repository that's connecting ChatGPT to PyAuto GUI. So you can say something like
Oh,
open, write an introduction in Notepad, and then we'll open Notepad and write something.
oh, that's great.
That's a thought.
Wait, what's the name of it?
Let me send it over. Looks like it looks like not. This is just a proof of concept, but this is the repo. So yeah, that looks like that would be kind of fun.
Yeah, I implemented it like in the college. Hosted a server, same Flask server on a PC,
Mhm.
and at that time I didn't want anyone to use that specific computer in the computer lab. So I run that Flask server, and whenever someone tried to use that computer, I just shut it down using my mobile.
That's cool. Yeah, that's cool. I did some stuff like that back in the day. Cool. Well, yeah, I gotta go, but this has been fun, and yeah, let's keep chatting. Hopefully, you can also join maybe when we're doing some other Python projects, and we can maybe do some small team projects as well.
Yeah, sure. I'd be really happy to do that.
Cool. I'm gonna make the schedule today for the rest of the week, and I'll send that over to you.
Yeah, sure. I'll be waiting.
Awesome, man. Well, have a good night. Mhm.